A very good morning, children. Welcome back to the physics class. How do things move in real life, children? For example, if you consider a ball moving on a flat ground, there is no external force is applied to stop the ball. Will the ball eventually come to rest after some time? Yes, it is. Have you thought of a reason, children? Let's consider another example. Say you are skating on icy rink and your friend is skating on the road. Whose movement will you think smoother? Definitely it is yours. When you hold a bottle in your hand, why doesn't it slip down and fall, children? Sometimes when you're walking around in a mall, do you see a caution sign to warn you about the flobbing wet? What explains all this, children? The answer is friction. The reason why the ball eventually come to rest is because of the force of friction. The reason why the skating on an icy rink is easier because of the force of friction is lesser there in the icy rink surface than the road. The bottle does not slip through because the force of friction between your hand and that of the bottle does not allow it to do so. If the floor is wet, the friction offered by it reduces and there are chances that you might slip and fall. Then, what is this friction actually is? Friction is nothing but it is a force. You have already studied in previous class, that is in the chapter force and pressure, that the friction is a type of contact force. It is a force exerted by a surface when an object moves across it. In the first case, when the ball is moving in this direction, the force of friction will act in the opposite direction. The force of friction offered by the icy ring is lesser than the force of friction offered by the road. Hence, skating on an icy ring is easier than the that of the road. Therefore, it will be easier and it seems to be effortless. The bottle does not slip down because the surface of your hand offers the friction in the upward direction. And in case of the floor in the mall, the soapy water reduces the friction offered by the floor. Then we were going to study about the factors affecting friction. For that, let us consider one example, children. Consider a cube placed on the table. We know that if we are pushing the cube, suppose in this direction, then already we have learned that the force of friction will act always in the opposite direction. If you apply the force towards the left, then what will be the force of friction, children? It will be towards the right hand side. The force of friction will always oppose the applied force. Then what are the factors that are affecting friction? Now, let me give you the three situations, children. You need to tell me what are the factors which influence the friction, or I can say the friction depends on the factors. So, in the first situation, here, when an object, just consider an object, say I have taken a ball, that is a smooth object, is moving on a smooth surface. And in the second case, there is a rough object which is moving on a smooth surface, or a smooth object moving on a rough surface. In the third situation, I have got a rough object moving on a rough surface. Now, what do you think of out of these three situations? Which one will have the highest friction? Just observe first situation, smooth object, smooth surface. second situation is a mixing of smooth and rough, isn't it? Rough object moving on a smooth surface or smooth object moving on a rough surface. The third case is both the object as well as the surface are rough. Yes, so your guessing is correct. The friction will be highest in case of the third situation than that of the second, than that of the first. Then, when do you observe that which situation will give the lowest friction, children? Is it the first or the second or the third? Yes, your guessing is correct. It is the first situation. That is, the smooth object and the smooth surface will always reduce the friction when compared to the rough object and rough surface. Therefore, it will be in the order. So, the friction will be greatest in the third situation than the second than the first. Okay. So now, what is the first factor we can say which is influencing the friction? Yes, we can say it is nature of both surfaces. When I say nature of both surfaces, it is not only including the surface of the object, but also it includes the surface of the surface. Okay. So, whether on which it is moving. Now, let us consider an inclined slope on a table. Okay, you can also prepare such an inclined slope on a table like this and mark a point somewhere on the this one that is inclined slope. Now, from this point, allow a small cylindrical shaped object. This is a small cylindrical shaped object to move down. Just observe, children. You will observe that it reaches particular point and then stops, isn't it? It reaches a particular point and then stops. Now what you have to do is place a sandpaper just right on the slope, okay, and leave the object, that is the same object, cylindrical object, from the same point. Earlier also I considered the cylindrical object from this point. Now also I am considering the cylindrical object from the same point. But the difference is earlier I did not use the sandpaper. Now I am using the sandpaper. Okay. Now you will see that, just observe, I am just leaving the cylindrical object from the same point, but just by using the sandpaper, just observe the movement of the cylindrical shaped object. What do you observe, children? Yes, you will see that the distance covered by the object is lesser in the second case. When I use the sandpaper, the object did not move to the extent when it was without the sandpaper. It is just observe. You know the reason why, isn't it? Because the sandpaper is a rough surface. Okay. The surface on which the object rolled is rougher in the second case, and clearly the force of friction is also more. Just now we have studied that rougher the surface, more will be the friction. Just now we saw three situations, isn't it? More the rough the surface is, then more will be the friction. Then why is that friction caused? Okay, we need to find out, isn't it? It is caused due to the irregularities. It is a new word, isn't it, children? Irregularities. Even though, so I take a table or a slope, it is just looking like a smooth surface, isn't it? But if we look into its surface, so just observe, or if we look into the surface of any of the smooth surface, we can find some irregularities. We call these irregularities as the surface irregularities. Even the surface of the object also, as I've said, cylindrical object, the surface may look smooth, but still the surface of the object also has irregularities. So, though they are minor, still they exist. The irregularities on the surface will lock into each other, and so whenever we need to move any object, we need to overcome the irregularities. But why is the friction higher in the rougher surface? So it is because, just observe, children, in the sandpaper, just observe the surface irregularities with that of the object or with that of the table. Okay. Just observe the type of irregularities. The irregularities on the table as well as on the cylindrical shaped object, they are lesser when compared to the irregularities on the rough surface. It is because the rougher the surface, more will be the irregularities. If the irregularities are more, then more force is required to overcome them. So, the first factor affecting the friction is the nature of the surfaces, isn't it? So, just consider another example, children. Let us say that there are two bricks. I have considered two bricks on the table. One weighs 2 kilograms, okay, and say another brick weighs 5 kilograms. Now what I'll do is I'll apply equal force on them towards the right hand side. Okay, which brick do you think will move faster, okay, or farthest? I can say. Remember, both bricks are on the same surface and surfaces of the bricks are also the same. Okay, on applying the same amount of force, just observe children, on applying the same amount of force, what do you notice? Yes, 2 kgs brick is moving or covering larger distance when compared to the 5 kg brick. What does it infer, children? It tells us that the friction also depends on the force with which the two surfaces are pressed together. So, if the two surfaces are pressed harder, the friction will be more. In our this situation, earlier situation, I have taken the 5 kgs, isn't it? So, here, as the weight of the 5 kg brick is more, then it presses on the table with greater force, isn't it? Since the brick surface and the table surface are pressed harder, the interlocking between the irregularities is more, and this results in the more friction. As the weight of the brick is more, interlocking between the irregularities is also more, and more is the friction. So therefore, we can conclude that there are two factors on which the friction depends. What are they, children? The very first factor we studied is the nature of both surfaces. So that is the surface irregularities of the object as well as on the which surface it is moving. If the surface irregularities are more, that means the rougher the surface, the more will be the friction. If the smoother the surface, the friction will be lesser. And what is the second factor, children? The second factor which the friction depends on is the force with which the two surfaces are pressed together. If the interlocking between the object and the surface is more, then I can say the more will be the friction. Okay, so I hope you have understood the concept about the meaning of friction and the factors which are affecting the friction. So now it is the time to take down the homework, children. The first question is define friction with an example, and the second question is mention the factors affecting friction. Okay, now you have to write down these questions in the notebook and write down the answers. So, thank you for watching the video, children. We will meet again in the next class.